Today we will discuss the basic concept of a very important idea of log. It's a logarithm. In log we actually rely mainly with indices. In indices we have a base and power is p and the result is n. This is a basic idea of indices as base, power and number. That implies if I write in logarithm form, then it will be log. Log is on the number n, that is log of n to the base b, and the result will be p. So log is in one word the power. So it is the power of a particular base, and we have to have a particular base. Normally we take, that is commonly we take base is 10. So most of the cases in algebra, most of the cases common base we consider as 10, but in calculus when we discuss, the base is taken as e. E is a special number in mathematics, e, small letter e, but we are mostly considering the number base as 10. Now if I take an example like log 243 to the base 3, then what is the value? We have to think how many times we will multiply 3 to get 243. We will be getting 5 times because 3 to the power 5 gives you 243. So here we are getting the power as 5. Therefore the power, this power is the answer, and that will be 5. Therefore in the case of log, what we have is how many times the base will be multiplied to get the result. Normally in algebra, if we find log anything like log x, if I write normally without any base, we imply that this is base 10, that is x to the base 10. This is the concept of log, basic idea. Now we have some fixed properties with fixed base, normally with base 10. The properties are, first property is log a plus log b. In both the log, the base should be same. Normally we take 10, it may be anything else, then the answer will be log of a into b. The second one, log of a minus log of b. Base is again same, that is normally 10. The result will be that same log base, and the final answer will be a by b. So in the case of log, if we add log with same base, the result will be log multiplied inside, and the subtraction leads to divide. Third property of log is when we take log a to the power m, then our result will be the same base m log a, that is power will come before the log and a will remain as a. That is the third property. Two more very basic properties are there. Log 10 to the base 10 is 1. That means if I write log 10 only, it will be 1 because base is normally 10. And if I take like log any base to the base b, same base and the number, then also it is 1. That means log 2 to the base 2 is 1, log 3 to the base 3 is 1, etc. So main property of log 4. Another main final basic property of log is log 1 any base. Log 1 with any base is 0. So log 1 to the base any number without a base is known to us, it will be always 0. Log 1 is 0. Now we have very important idea that if we need to change the base, these are all fixed base, these properties are fixed base are same, but if we want to change the base, how to change the base? Change of base, then we have a very basic idea that log a to the base b, we don't have the base to be 10, and if we need the base to be 10, then we can write log a by log b. In both cases the base will be 10, or instead of 10 we can take the same base, that is log 2 here base log a to the base 2 and here log b to the base 2, any base. So base will be same, then we will write log a by log b as log a by b. So here we can have a reciprocal concept that if I change the numerator and denominator, the numbers will be interchanged. That means if I write log b to the base a, it will be reversed, that is log b by log a, and leading to the idea that it will be the reverse of log a to the base b. So if I write log b to the base a, and if you take the reciprocal of that, then it will be log a to the base b. So this is another important property of log when we need to change it. Now we have some examples of log, some algebraic examples. One problem will be like this. Examples: 2 log 5 base 20 plus, we have to find the value, 2 log 5 to the base 20 plus 4 log 2 to the base 20. We have to find the result. This is a find the value. We want to find it. So what you can do, this 2 I can take the power, because log 5 to the base, log 5 to the power 2 will be 2 log 5. So if I take the reverse way, it will be log 5 to the power 2 base 20 plus log 2 to the power 4 base 20. It is log 25, and this is base is 20. This is log 16, base is 20. So when we are adding the same base, numbers will be multiplied. So it will be log 25 into 16, and the base will remain as 20, and the result is coming to 400. 400 base 20. Now what is 400? 400 is 20 square. So final result will be 2 log 20 whole square, and the base is 20. So 2 log 20 to the base 20. This means these are equal. So our answer is 2. So this way we can simplify log with the algebra instead of calculating the value. Now if we have some more results that may be like log 2 base 10 is x if, and another example, this is second one, log 3 to the base 10 is y, and find log 15 to the base 10. How to solve? Now here what you are finding, that 15 is 5 into 3. The solution will be log 5 into 3 base 10, because 15 is log 5 into 3, which can be written as log 5 plus log 3. Now we don't have any problem with log 3. We know the value to be y. But what about 5? Yes, we can write 5 as 10 by 2. 10 by 2 is 5. So we can write 10 by 2, and this is log 3 to the base 10. Now log 10 by 2, that is log a by b. Log a by b, when we simplify, it becomes log a minus log b. Log a minus log b. So our result comes to log 10 to the base 10 minus log 2 to the base 10 plus log 3 to the base 10. So our answer is 1 minus x plus y. So this is the final answer to find out what is log 15 in terms of x and y. Another problem we can have, like log, find log base 3, then log base 4, and then log 16 base 2. So this is the question. What we do, we will be starting from the inside part, that is 16 base 2. What is log 16 base 2? It will be 2 to the power 4, because 2 to 4 times gives you 16, and the base is 2. So we need to have base 2, that is why 2 to the power 4. So 4 comes before here. It will be log 3, then the bracket log 4 base, and this is 4 log 2. Now 4 log 2, this 2 and 2 base are same, so it will become 1. therefore this is 3, and log 4 base is 4, so it will be 1, because that is 1. 2 to the base 2 is 1, so we can have log 4 only, 4 into 1, and finally we are getting again this is 1, so log 1 base 3, and log 1 any base is 0, so the result will be 0. So this type of problems we can have in order to simplify log and get the result. Now one change of base problem, like evaluate change of base. Find 1 by log 30 to the base 6 plus 1 by log 30 to the base 5. In these two values, log, base is not same and number is same, so we have seen the reciprocal property of log. If I change the base, it will be log, this is reciprocal, it will be log 6 to the base 30, and this will be log 5 to the base 30. Now the base is same. In this case base was not same, we cannot do anything. Now the base is same, so we can take 30 as base, 6 into 5, and 6 into 5 is 30, so our final answer will be 30 to the base 30, and it is 1. So it is a concept of base change of base. Another problem we can take for change of base, find the value of x. Find the value of x. Find x or solve x. And the question is log x to the base 4 plus log x to the base 8 is equal to x to the base 4 and log x to the base 8 is equal to 10 by 3. What we need? We need to solve x. Now here what we can do, we can take the concept of log a by log b. Log a is log x by log 4. Log a is log x by log b, the base, and this is log a by log 8. So it is log a by log 8. In this case, this is 10 by 3. So what we can see, that is log 4 is 2 square. 4 is 2 square, it will be 2 log 2. And this is 2 to the power 3, it will be 3 log 2. So this is equals to 10 by 3. Now if we see the result, we can have the common part, that is log x is common in both numerator, both the numerator of this expression, and log 2 is common in both the denominator. So we can take log x by log 2 common, and leaving there half 1 by 2 plus 1 by 3, that is equals to 10 by 3. If we add, this is 5 plus 2 10, sorry 5 plus 2 3 plus 2 5, 3 plus 2 5, taking the LCM, this is 3 plus 2 5, 3 plus 2, this 2 will be added is 6, and this is 10 by 3. So now we are calculating what is the value of log x in terms of log 2. So we can cancel this 5 and this 10 with 2, and this 3 and this 6 with 2. That means we are cancelling 5 and 10 as 2 and 3 and 6 as 2. So what you are finding, this 2 will be taken this side, that is log x by log 2 is 4. Now we can multiply, cross multiply, log x is equal to 4 log 2, and 4 log 2 means 2 to the power 4 in the simplification part, that is log 2 to the power 4. Therefore x will be, if I take the removing log from both sides, which is also known as anti-log concept, we are taking log removed from both sides and leaving behind x, and x is 2 to the power 4, that is 16. So the result of this question, final answer is x will be 2 to the power 4. This is a long method I have followed just to discuss the idea of log with some properties. So these are the some few problems of logarithm with fixed base, and some are with change of base. That's all for logarithm today.